How's it going, guys? Today in this video, we're going to be going over 10.3, day 1, solving rational equations. So before we can actually solve a rational equation, we need to figure out how to solve for our LCD, or our least common denominator. All right? So these two excerpts here, you can read on your own if you want to. I'm going to go straight to example 1 and read how to actually solve for our LCD. So what we're going to do is we're going to factor each denominator completely. And when we say completely, that also means the constant terms, we need to factor that down into a prime factorization. And we'll see what I mean by that when we go over the problem. Next, we're going to list the different factors, or rather list each distinct factor. After that, we're going to take the highest power of each factor and multiply it together. And then from there, that's going to give us our LCD. So for number 1, what we're going to do is factor out the denominator first. So the bottom, we can factor out a 3. And we're left with an x minus 5. And then for the second fraction, we can factor out a 4. And when we do, we're left with an x plus 7. But when we factor out that 4 has a prime factorization of 2 times 2. Or in other words, 2 squared. And we always want to write our factors with a power if we can. All right, we don't want to write 2 times 2, we want to write 2 squared. All right. And once we factored out our denominators completely like this, and we took the prime factorization of our constants, what we're going to do is list out each individual factor. First one I see is 3, then I see an x minus 5, then a 2. We're not going to write the powers here, we're just going to write the factor itself, and then x plus 7. So once we listed out each of our factors, or once we list out each factor, what we're going to do now is we're going to rewrite each factor, but with the highest degree that we see in either fraction. So the highest degree of 3 that I see is just 1. We'll multiply that with x minus 5 with the highest degree we see of that. The highest degree we see with x minus 5 is just 1. The same thing with 2. The highest degree that I see with 2 is this 2 squared. So I'm going to write 2 squared. And the highest degree that I see with x plus 7 is just 1. So I'm just going to multiply with x plus 7. When I multiply all these out together, all I'm really going to do is multiply the constants. I'm not going to FOIL out the parentheses. There's no point. We want this in factored form. So 3 times 2 squared is just going to be 12. 2 squared is 4. 4 times 3 is 12. And we're leaving the parentheses as is. We are not going to FOIL that out. It's not going to do us any good. And that's not how we want it. So our LCD at number 1 is just 12 times x minus 5 times x plus 7. Okay, and now for number 2, we're going to go about it the same way. We're going to factor out the denominator as much as we can. The first fraction factors out into x minus 8 and x minus 3. And the second fraction, that's going to factor out into x minus 3 times x minus 3, or just x minus 3 squared. We don't want to leave it as x minus 3 times x minus 3. We want to write it as x minus 3 squared. So from here, I'm going to list out each distinct factor, or each different factor. So x minus 8, that's the first one I see. And then I see x minus 3. And then I see x minus 3 again. I'm not going to rewrite it. I only want to list out my different factors. So x minus 8 and x minus 3. Or in other words, my denominators are made from x minus 8 and x minus 3 only. From here, I'm going to multiply them together. And I'm going to multiply it with the highest degree exponent that I see. So for x minus 8, the highest degree that I see in either fraction is just 1. So it's just going to be x minus 8 to the first power. And for x minus 3, the highest exponent that I see with x minus 3 is this squared over here. So I'm going to write x minus 3 squared. And I'm not going to FOIL it out. So that right there is my LCD. Okay, so let's go on to number 3. For number 3, we're going to go about it the same way. We're going to factor out the denominator and then get the prime factorization of each constant term. So for number 3, we have x plus 6 all over 8x minus 24. We can factor out that 8. And when we do, we're left with an x minus 3. And that 8, the prime factorization of it is 2 times 2 times 2, or just 2 to the third. And then for the second fraction, we have 14x all over 10x minus 30. that 10x minus 30, we can factor out a 10. And when we do, we're left with x minus 3. And that 10 has a prime factorization of 5 times 2. All right? So now that we factored out the denominators and figured out the prime factorization of the constant terms, we're going to write out each distinct factor that we see. So the first one I see is 2. Then I see an x minus 3. Then I see a 5. And then I have another 2, but I already have it written down, so I don't need to write it twice. And then another x minus 3, but I already have it down. I'm not going to write it twice. I only want to list out each different factor. I don't want to write factors twice. Okay, so now for my LCD, I'm going to get that by multiplying each distinct factor that I have listed out with the highest degree that I see in either fraction. So for 2, the highest degree of 2 that I see in either fraction is 2 to the third. So I have 2 to the third. For x minus 3, the highest degree that I see in either fraction is just a 1. So it's x minus 3 to the first power. And same thing with 5. The highest degree that I see, or the highest exponent I see with 5 is just a 1. So I'm just going to multiply it by 5. And when I multiply this all out, 2 to the third is 8. 8 times 5 is 40. I have 40 times x minus 3. And that's my LCD. And what we can see here, and why we actually have to figure out the prime factorization, is that when we multiply all this LCD here, we didn't multiply with this 2. And not multiplying with that 2 from the prime factorization is really important, because if we did multiply with that 2, we would have gotten 80 times x minus 3. And that would not be the correct LCD. So let's go ahead and actually redo this problem again. Let's redo it without getting our prime factorization. So if we didn't get our prime factorization, we would have done x plus 6 all over 8 times x minus 3 and 14x all over 10 times x minus 3. Okay? So from here, if I listed out each distinct factor that I see in the denominators, I would have gotten 8, x minus 3, and 10. The highest power of 8, x minus 3, and 10 in any of these denominators is just 1. So I end up getting 8 times x minus 3 times 10, or simply 80 times x minus 3. That's not the least common denominator like we saw on the left side. Our real least common denominator is 40 times x minus 3. So the way in red that I did over here is incorrect, and that's because 80 times x minus 3 is too big. It's not our least common denominator. When we saw 40 times x minus 3 as our least common denominator. All right? So that's why you need to find the prime factorization of each common denominator to figure out your LCD. All right, for number 4, I'm going to let you guys do that on your own. You can double check your work on Canvas. We have our completed notes there. But for now, I'm going to keep on going. We're going to actually talk about how to solve rational equations algebraically using this LCD that we just talked about. So the very first thing we're going to do is we're going to figure out all our excluded values. So that means sometimes we might have to factor the denominator to get us to a point where we can find our excluded values. Another word we're going to be using instead of excluded values is going to be this word right here, restrictions. It's the same things. Our restrictions are going to be our excluded values. Okay? So they can be used interchangeably. Your restrictions are going to be your excluded values. So don't be confused by the wording. It's very, very identical. Pretty much the same thing. So once we figure out our excluded values, the next thing we're going to do is identify the LCD. And once we get our LCD, we're going to multiply through the whole problem with our LCD. We're going to multiply each fraction by that LCD. And the reason we do that is because the LCD is made from the denominators. So each denominator is actually a factor of the LCD. Or in other words, when you multiply any fraction by our LCD, the denominator is going to go away. So that's why we're going to multiply the fraction out by the LCD. And you'll see more what I'm talking about when we actually do a problem. That goes with number 4. We're going to divide out common factors. So we're going to get rid of the denominator. And after that, we're going to solve the resultant polynomial equation, or we're going to solve for x. And then step 6, we need to double check that solution with our restrictions, because if our solution is actually an excluded value of the original equation, that solution is going to be called an extraneous solution. Hopefully I spelled that right. But an extraneous solution, what that means is just that it's I don't want to say an extra solution, but it's a solution that doesn't work with a problem because it's an excluded value. Or you kind of think of it as like a fake solution. It's not a real solution. You might have solved for it and got an X value for it, but it doesn't work with the problem, so it's not a real solution. It's an extraneous solution. Okay? So now that we've talked about it, let's actually do a problem and see what we're talking about. So for number 1, we have 5 over 6x plus 3 over 4 equals 19 over 12x. So the very first thing we want to do is we want to figure out our restrictions or our excluded values. So we're going to set each denominator equal to 0. When 6x equals 0, we get that x equals 0. So that's one restriction, x cannot equal 0. And when 4 equals 0, that doesn't make any sense. 4 can never equal 0, so that does not give us a restriction. And when 12x equals 0, we also get that x equals 0. We don't need to write that twice, so our restriction is still just going to be x cannot equal 0. So that's all our restrictions, all our excluded values. So once we've done that, we're going to figure out our LCD. All right? So to figure out our LCD, we're going to figure it out for all 3 denominators, 6x, 4, and 12x. So first thing we're going to do is get the prime factorization of the constant terms. So 3 times 2 times x plus 3 all over 2 squared equals 19 all over 3 times 2 squared times x. Okay? So that's the completely factored out version with the prime factorization. And now we're going to list out each distinct factor on the denominator. All right? So the first one I see is 3, then a 2, then an x. And everything else in the other 2 denominators are all made by 2's, 3's, and x's. So that means all our distinct factors on the denominator is 3, 2, and x. So now we're going to multiply 3, 2, and x with the highest degree of each one. So the highest degree of 3 that I see in any of these 3 fractions is just 1. So I'm going to multiply by 3 to the first power, or just 3. For 2, the highest degree of 2 that I see is a 2 squared, both here and here. So just 2 squared. And then for x, the highest degree that I see is just a 1. So you multiply it just by 1. So when I multiply this all out, 3 times 2 is 2 squared is going to be 12. 2 squared is 4. 4 times 3 is 12. So our LCD is 12x. So now that I figured out my LCD, we're going to take it and we're going to multiply it with each fraction. And when I do that, I get 5 all over 6x times 12x plus 3 over 4 times 12x. That all equals 19 over 12x times 12x. So I multiply each fraction by 12x. And when I do that, I'm not changing the value of the whole equation because I'm multiplying everything by the same value. So the value of the equation doesn't change. And so what we're doing is perfectly okay. So from here, I'm going to cancel out the denominators. So 12x divided by 6x in this first fraction. These can actually cancel out to give you just a 2. 12x divided by 6x is just 2. So we're left with 5 times 2. For 3 over 4 times 12x, 12x divided by 4, that's going to give us 3x. So we're left with 3 times 3x. And lastly, we have 19 over 12x times 12x. 12x divided by 12x is just 1, so we're left with just 19. So now we're going to solve this all out and actually solve for x. 5 times 2 is 10. 3 times 3x is 9x. And that's all going to equal 19. All right, so now we're going to solve for x. We're going to minus the 10 over. We get 9x equals 9, or simply x equals 1. So now that we have a possible solution for x, we need to double check it with our restriction and make sure it's not part of our restriction. And this problem, it isn't. So x equals 1 is a solution. So our only solution to this problem is x equals 1. Okay, let's go on to number 2. For number 2, we're going to go about it the same way. first thing we need to figure out is our restrictions. So we're going to set each denominator equal to 0. And 1 is the same thing as 1 over 1, so our denominator there is just 1. So when x plus 2 equals 0, we get that x equals negative 2. So our restriction is x cannot equal negative 2. 7 and 1, both those denominators can never equal 0, so they're not going to give us any restrictions. All right, so from here, now we're going to figure out our LCD. So we figure out our LCD, we're going to make sure it's all factored down, and we have the prime factorization of all our constants. And it's already factored down for us, so we don't need to do anything. We're just going to go ahead and list out all our distinct factors. So the first one I see is x plus 2. Then I see a 7, and then I see a 1. Each of these only has a highest power of 1 throughout the whole problem. So our LCD is just going to be 7 times x plus 2. So we have our LCD, and now we're going to multiply each fraction by that LCD. So we have 10 all over x plus 2 times 7 times x plus 2 minus 3 over 7 times 7 times x plus 2. That all equals 1 over 1 times 7 times x plus 2. All right, so now that we have this, what we're going to do now is we're going to cancel our denominators with our LCD. So for the first fraction, this x plus 2 and this x plus 2 cancel out. We're left with 10 times 7, or just 70. For this negative 3 over 7 times x plus 2, these 7's cancel. We're left with a negative 3 times x plus 2. And lastly, we have 1 over 1 times 7 times x plus 2. That's just going to give us 7 times x plus 2. All right, so what we're going to do now is distribute that negative 3 in that 7. And when we do, we get 70 equals negative 3x minus 6 equals 7x plus 14. So now we're going to add like terms, and we're going to solve for x. So I can add the 70 and this negative 6 to give me 64, and add this 3x to the other side, and I get 64 equals 10x plus 14. Then I just minus that 14 over, and I get 50 equals 10x. Divide by 10 on both sides, and I get that x equals 5. So that's really ugly. X equals 5. So I have one possible solution of x, and now I'm going to double check it with my restriction and make sure it's not part of my restriction. So x equals 5 is not part of my restriction, so I'm perfectly okay, and that x equals 5 is a solution. Okay? So that's number 2. For number 3, I want you guys to do that on your own. You can double check your work on Canvas, but I do want to go over number 4, so I can actually show you guys what an extraneous solution, a problem with an extraneous solution looks like, what it looks like when you have an extraneous solution. So for number 4, the very first thing we want to do is get our restrictions. So we're going to set each denominator equal to 0 and solve for x. So when x minus 7 equals 0, we get that x equals 7. So x cannot equal 7. 2 cannot equal 0, so that does not give us a restriction. And then x minus 7 equals 0 for our last denominator. I've already solved that out. It gives us x equals 7. We don't need to write it twice, so we have all our restrictions listed out. Next, we're going to figure out our LCD. So we need to make sure our denominators are completely factored out, and each constant has a prime factorization. We see that it's already set out like that, so we're good to go. We just need to list out each distinct or different factor. So the first one I see is x minus 7. Then I see a 2. And I have another x minus 7. I don't need to write it twice. And now I need to figure out my LCD by multiplying each of these distinct factors together with the highest power that I see in the denominator. Or in other words, my LCD will just be 2 times x minus 7. The highest power of x minus 7 that I see is 1, and the highest power of 2 that I see is also 1. So my LCD is 2 times x minus 7. So now that I have my LCD, I'm going to take it, and I'm going to multiply it with each fraction that I see. So 2x minus 9 all over x minus 7 times 2 times x minus 7 plus x over 2 times 2 times x minus 7. That's all going to equal 5 over x minus 7 times 2 times x minus 7. Kind of ran out of room, but that's what it's going to be. So now that I multiply each fraction by x minus 7, what I'm going to do is cancel out my denominator. So for the first fraction, this x minus 7 and that x minus 7 cancel out, and I'm left with 2 times 2x minus 9. For x over 2 times 2 times x minus 7, these 2's cancel out, and I'm left with x times x minus 7. And for my last fraction, on the other side of the equation sign, the x minus 7's cancel, and I'm left with 5 times 2, or just 10. All right, so now I'm going to distribute out this 2 and this x. And when I do, I have 4x minus 18 plus x squared minus 7x, all equals 10. So now I'm going to add like terms. And I see I have an x squared here, so that tells me that I'm probably going to have a quadratic I need to solve out. So I need to make sure everything is set equal to 0. So I'm going to rewrite this while subtracting the 10 over. So x squared, 4x, and negative 7x gives us a negative 3x. And negative 18 minus 10 is negative 28. And that's all going to equal 0. So I do have a quadratic. And now if I have a quadratic set equal to 0, that means I just need to figure out my factors of that quadratic, and that's going to be my solutions. So when I factor out x squared minus 3x minus 28, I get x minus 7 times x plus 4, and that's all going to equal 0. So my solutions are x equals 7 and negative 4. All right? So these are my two possible solutions, but I need to double check both of them with my restrictions to make sure we're not, that neither of these are an excluded value. So if I go back to my restrictions, I see that my only restriction is x cannot equal 7. But one of my solutions that I solve for is that x equals 7. So that means that that 7 is an extraneous solution. It's not a real solution. It's not going to solve my problem. It's just going to give me an excluded value. So we're going to cancel it out. And my only solution to this problem is x equals negative 4. So my extraneous solution is x equals 7, but my real actual solution to this problem is x equals negative 4. All right. For number 5 and number 6, I'm going to leave that for you guys to do on your own. This video is already getting kind of long, it's already 23 minutes. So I'll leave that for you guys to do on your own. You can double check your work on Canvas. The completed notes are already up. And hopefully this video helped, guys.